Dear AS students, in this video we go for the normal distribution, which is the last chapter of statistics 1 for AS level. In the previous part, you learned some properties and criteria for the random variables which are modeled by normal distribution. The main and major property for normal distribution is that the normal distribution is used for continuous data, you know, in opposite to the binomial distribution, which is used for discrete data. For example, the number of success 0, 1, 2, 3, these are all whole numbers. But here in normal distribution, we just focus on continuous data, as normal distribution is used for just continuous data. Now, in the previous session, we learned that the function which calculates the probability for a normal distribution with mean mu and variance sigma squared is 1 over sigma radical 2 pi exp means exponential e to the power of this expression, which is negative x minus mu squared over 2 sigma squared. But I told you that it is for your level almost impossible to use this function to calculate probability, and as it is used for continuous data, so integration is used to calculate the probability for continuous data, so you don't know how to integrate this expression. Uh, so we are going to use another way in order to find the probability for normally distributed data. Now, let's see first some notations. If x is a random variable which has normal distribution with mu as mean and sigma squared as variance, it is denoted by this notation. So if x has normal distribution, n is abbreviation of normal, first element always represents your mean and the second element always represents variance. So it is the key point that you need to know. X with normal distribution mu and sigma squared describes a normally distributed random variable. We read this as x has a normal distribution. This means that x has a normal distribution with mean mu and variance sigma squared. Now, there is another important point that you need to know when you want to find the probability of x lies between a and b. In the previous session, we learned that when x has normal distribution, the graph will be always bell-shaped like this. Here is mu is the exactly midpoint. Now, I'm going to find the probability of x is between a and b. Okay, let a be somewhere here and b is somewhere here. So it is a, it is b. It is not necessarily symmetrical. Okay. X is to be between a and b. For example, x is, I don't know, a is negative 2, b is 5. But if it was binomial distribution, you can say that the values between negative 2 to 5, for example, negative 1, 0, 1, 2, 3, 4. Or here, because you have it as equal, so negative 2 and 5 are included. But it is continuous data. There is an infinite number of data between these two numbers. We cannot calculate one by one. So you need to find area of this shaded region. You need to find the area of this shaded region. Then, how do we find area of this shaded region? I told you that was the function which is used. But calculating integration or area through that function for your level is impossible. In your level, all calculations have been done and calculated and summarized in a table which is on your page 22 of your book in file is 233. You see here all calculations are already done here and summarized here. So from now on you can use this table to find the probability. There is no need to go for integration. Now let's go back now. It was here. Now, so if you want to find probability of x between a and b, actually you are supposed to find the area. You are gonna learn in pure mathematics in integration chapter how to find integration. A and b, f of x, d of x. Integration of function between this lower bound and upper bound gives you the area under the graph. It is area under the graph that you will see completely in your pure mathematics. Now, how to use table and to find the probability now. First, we start with a standard normal variable because the table gives you just information concerning standard normal distributions. So I first, for a standard normal variable z. Z is mainly used to denote a standard normal variable. Now, consider the case that your random variable has normal distribution with and the normal distribution is a standard. What does it mean, a standard normal distribution? A standard normal distribution is the case in which z has normal distribution and mu should be 0, mu must be 0, and variance must be 1. As you see, z has the normal distribution with mu and sigma squared. So in a standard case, mu is 0 and sigma squared will be 1. If it is not a standard, I will teach you how to make it a standard in following parts. Now, let's see how to use this table and these properties in order to find probabilities for some given normal distributions. Now, look at example 8.1. It says given that z has normal distribution with mu 0 and variance 1. So it is already standard because mu is 0 and variance is 1. It says find the probability of z less than 1.3. Less than 1.3. Now, just let me tell you one notation before. If you have again a normal distribution, it is for example point A, and you are supposed to find this area. This area of this shaded region is denoted by phi of A. So phi of A is area of this region. Phi of A means area under the graph before point A. Before point A. I will repeat. Phi of A means area under the normal distribution curve before A, not after A. Okay, now let's go back to the example. We saw that it has normal distribution, mu is 0 and 1 is the variance. It says find the probability of z less than 1.3. So as mu is 0, mu is exactly the midpoint, the symmetrical line, the line of symmetry. So 1.3 lies somewhere here after 0. It says probability of z less than 1.3. Probability of z less than 1.3, it means that all the variables before 1.3. So it is this region. Okay, probability of, I write it here, probability of z less than 1.23 is equal to, we learned this notation, probability of z less than 1.3 will be phi of 1.3, because phi of 1.3 means the area under the graph before 1.3. It is exactly the same thing, and you see in the diagram. Now I go to the table 2 3 2 3 3. So now we are looking for phi of 1.23. This table gives you all phi is equal to. Now we should find 1.23 in your table. Here 1. See here, it gives you the first two digits. 1.2 is here. So you should look for the required number in this row. It says 1.23. In the first column, it is 0, then 1, then here. Do you see in this column, this is the probability for this number, 1.2, and 3 is here, above. So 1.23. So phi of 1.23 is 0.8907. 0.8907. Now I go back to the file. Now next part, you see it is phi of 1.23. Now next part wants you to find probability of z greater than 1.23. Let me draw another. It is 0. 1.23 is here again, because 0 is there. Now you are looking for the region after 1 because it says greater than 1.23. But the table that you saw doesn't give you probability for a value less than a number. It gives you more than a number. It always gives you a value less than a number. Now, but we know that all region, it gives you the whole probability, and the whole probability is always 1. So we can write that this region is 1 minus phi of 1.23, because this region is phi of 1.23. So we need this region, so I write 1 minus phi of 1.23. We already found it. It was 1 minus phi of 1.23 is 8,907. So if you subtract it will be 1093. Now let's go for the next example. Again, it says that given that z has normal distribution, now at this step you have just standard normal distributions because you don't know how to standardize it. So again, it has normal distribution, which is a standard. Mu is 0, variance is 1. It says find the value of z between 0.4 and 1.7. Now let me open another page. Again, it is 0. It says between 0.4, for example, 0.4 is somewhere here. 1.7 is here. It says between these two values. Between these two values. Now, if I calculate the region before 1.7, it gives you the whole. And if I calculate phi of 0.4, it gives you the region before 0.4. I repeat, phi of 1.7 is the region all before. Phi of 0.4 is all the region before 0.4, but I need the region in between. So in order to find probability of z between 1.7 and 0.4, you should calculate the region before 1.7 minus the probability of region less than 0.4, because if I subtracted this region minus this region, it gives you this region in between. I hope you understand. Now it will be, what is probability of z less than 1.7? It is phi of 1.7 minus, what is probability of z less than 0.4? It will be phi of 0.4. Now let's go to the table to find these numbers. It was in my file is 2.33. Now again, so phi of 1.7, 1.7 is already here. 1.7 means 1.70, so it is, this is the number. Look at the pointer, you will see it is 0.9554 minus phi of 0.4. 0.4 is here, 0.6554. Then I go back to my file, page 208 if I'm not mistaken. Yes. Now, do you see? These are the numbers we found here, these two numbers. So if I subtract them, it will give you 0.300, as it says, 3 decimal places. Now, so let's now see some points here. If you are supposed to find probability of z less than b, z less than b, I just told you, it means that phi of b, because phi of b, that table gives you just phi values, gives you the area of the region before b. So probability of z less than or equal to b is phi of b. If you want to find the area after b, z greater than b, you should subtract phi of b, which is this shaded region, from 1. So 1 minus phi of b will be probability of z greater than b. Okay, probability of z greater than b. Now another point that you need to learn, that table never gives you the on the page 222 never gives you the value for negative numbers, but we know that our graph is symmetrical, so we use this property. When it says phi of a and probability of z greater than a negative number, this number, do you see this region? Is this region the same as this region? I mean, in terms of area, they are the same. They are as if, reflected. As you see, they are reflected. So when you are looking for probability of z greater than a negative number, so you can find phi of positive a. It is as if reflected here. Let me show it in my paper, then you will see. For example, you are looking, it is 0. A is a negative number. You are supposed to find probability of z greater than negative a. Now, so my table doesn't have any value for negative numbers. I draw another one, it is 0. Negative a, I reflect it, I put it here, it will be positive a. Okay, for example, if it is negative 1.7, I make it positive 1.7. But this region, which is asked here, is the same as this region. So phi of, probability of z greater than negative a is the same as phi of a. So if you are looking, look at the diagram. If we are looking probability of z greater than negative a, it will be 1, as you see here. It will be, phi of a. Probability of z greater than negative a is exactly phi of a. Okay. Now next case actually. If you are looking for probability of a negative number, z less than a negative number, I consider here as mean. For example, it is negative a. You are supposed to find this number. This, I mean, area. Again, it will be phi of negative a, which is undefined in your table. But what can I do? I convert it to this case. 0, it is negative a. I make it positive a, it will be here. This region is exactly identical to this region. What is this region? 1 minus phi of positive a. So phi of, as a case, I mean, you can make a conclusion that phi of a when it is negative, when a is negative, is equal to 1 minus phi of positive a, I mean in opposite sign. Okay, now look at this case. Probability of z between negative 1 and 2.115 correct to 3 significant figures. I hope you all saw these cases now. So probability of z between 2.115 and negative 1. So negative 1 is here, 2.115 is here. So it will be phi of upper bound minus phi of lower bound. Let me write it for you. Probability of z between negative 1 and 2.115 is equal to phi of upper bound minus phi of negative 1. So, which is equal to phi of upper bound, you can easily find, minus, but phi of negative number is undefined in that table. So, it will be 1 minus phi of the opposite of negative 1, which is positive. So, it will be phi of 2.115 minus 1 plus phi of positive 1. Now, I will find them in the table one by one. First, I go for phi of 2.115. It's a special case. C, it deserves a careful attention because it has more digits. 2.33. It says phi of 2.115. Now, 2.11. 2.1 is here. Let me 2.1 is here. Let me make it smaller. I would like you to see all together. Now 2.1 is here. 2.11 until 2.11 is here. So remember 2.11. So let me write it somewhere. Phi of 2.11 until here will be 0.9826. But you have, see here again, it is not 2.11, it is 2.115. So you have a third digit, additional digit here. Additional digits can be found here. So 2.11 is here. So what column gives you 5 in this row? I mean in the same row. 2.11 is this row. What column gives you additional 5? 5 will be in this column. Do you see? Look at the top. It is 5. So again 2.11 is here. Then I go for the top 5. So which is 2. So 2 must be added to the last digit. If you add 2 to the last digit, it will be 0.9828. Again, till here it is 2.11, 2.11 actually. Then the third digit is 5. The third digit can be found here. The third digit is 5, 5 here. You find the digit here. Then see in the same row what digit it recommends you to add. It is 2. So it will be 0.9826. 0.9826 plus 2, which is 8 then. I should add now. Minus 1 plus phi of 1. Phi of 1, 1 is here, which is 0.8413. Okay, let's increase the size. Then I go back to the same page, 209. Now, then after calculating, it will be 0.824, as you see. Now, if sometimes phi is given, it is inverse. It is actually inverse of what we have been doing. Here, it says Z has normal distribution, standard normal distribution, and A is such that phi of A is 0.9072. See, phi of A is actually 0.9072. You should find A. You should find A is the question. Now, I go to the table. So probability is given, and you are supposed to find the corresponding number. It is 2.33. Now here probability, we know that probabilities are given inside the table. These are the, boundaries. These numbers, emerging numbers, these are boundaries. Now, 0 point, what was the number here? 0.9072. Let's see what gives you 0.9072. 0.907907, 0.907. Here we are, where is it? 907. Here we are close. It is the closest number, which is, see here, what is the corresponding number? This is it is close to 0.907, but it's not exactly 0.9072. Okay, so far, what does it represent? What is the boundary whose area will be this? It is 1.32. Again, 1.32 gives you, so I write it here, 1.32. A will be 1.32 plus. But we still need some value, a small values added to this to make it 0.972. How much is the difference between here 0.9066 and 9072? It is 0.006. It means that 6 must be added to the last digit. So 6. Now in the same row, see which number in the same row, which was 1.3. 1.3 in the same row, which digit is corresponding to 6? 6 is here. 6 is added to the last digit. Now I go up. Let me proceed. 1.3, it is this row. Then I go up. It is 4. So it means that it will be 1.32 and the last digit will be 4. So at the end it will be 1.324. 209. See here, this is the value of A. Now let's see some more cases here. It says again, Z has normal with 0 and 1. Find the value of B such that Z greater than B. Listen, the value of Z greater than B is 0.73. Okay, the value of Z greater than B is 0.7713. So definitely, because it is normal, and normal 0 is the mean, and as it is symmetrical, this portion, this half, the half of bell is 0.5, the half of bell is 0.5. It is 0.7713. 0.7713 after B, the area is 0.7713. It means that the area is more than half. The area is more than half. Definitely this B is a negative number. This number, this B is a negative number in negative values. Okay, So the table doesn't give you any information concerning negative numbers. So I should make it opposite. I make it positive 8. It comes here. This region is the same as this region. So we can say that phi of a number a should be 0.7713. 0.7713. So phi of a number is 0.7713. Now I go page 233 to see what numbers gives you 0.7713. 0.77 and 0.77 13 we don't have, but here it is closest, which is 0.74. We need 9 more, so it will be, we need 9 to be added to make it 13. So this is represented by 0.74, and to add 9 we need to have 3 at the end. So here 0.7713, here it will be 0. Sorry, here, so 0.74 and 0.74 till here, 0.743. This is, so 0.743. Let's go back. Do you see 0.743? But this is a positive number found, but we know that we made it positive. It was already negative. How can I make it, I mean, as the original number which was required, I just multiply by negative. So the original number which is asked in the question is negative of this number, which is 0. Negative 0.743. I hope you all understood this topic, which is really important and has lots of questions. Watch these videos carefully, then we will work on your problems in the class.